Video 3 is about interpreting these weighted effects that we just talked about, where we have unequal cell sizes, and now we need to interpret what those effects are. So if I begin with my means table, these are all the marginal means that we expected, or the computed means for all four of our pet types, as well as whether they make a mess or don't make a mess. But then what I want to show you is the difference in cell frequencies. And this is just relevant to emphasizing why it's important to use weighted effects, because these the means that are computed in this table right here are oftentimes interpreted as if the number of observations is equal or constant across each one of these cell means. But as you can see here, these are the frequencies that we've used, and it's no different than the table that I showed you before. So remember that when we're looking at the B's that we calculated from our linear model, the first thing that we did was we calculated the intercept. And the intercept here, when we calculate it using the standard method, we get 0.23. Now I'm going to go back up to this, and you can see that this is for the unweighted effects, we get 0.23. But for the weighted effects, we get 0.17. And the reason for that is that is a weighted aggregate, so it's a weighted mean. So the interpretation of the effects for weighted versus unweighted is pretty much the same. It's just the computations require weighting. Instead of having everybody go through all of the computations, because it can get really tedious, I want to show you just how to work backwards so that you can see. Cohen and Cohen do a nice job of this, but I think it's important to go through this on our own. So what I want you to see is how we get expected values from weighted versus unweighted effects. Now the interpretation and the direction remains the same. It's just the exact values of the marginal means are going to differ, and unless you calculate marginal means that are weighted, you're not going to get values that correspond to the observed values. So this is the way you want to look at it. Remember that pig is our comparison group. If I go back up here to our contrasts or to our effects codes, here we've got pig is -1. And remember that what we did was we weighted pig accordingly to the sample size, the cell size differences. Sorry. Now when we're going to calculate the expected value for pig as a main effect, we're going to calculate it the same way we've calculated all of the other effects for this comparison. We're going to take our intercept and we're going to subtract out B1, B2, and B3. These are our effects codes, but you notice that here now I've got the sample size for cat over the sample size for pig, that ratio, because this ratio here is the weight that is being used. Let me go back up here. Is the weight that's being used in our comparison. So this is the n of cat over the n of pig, and there are half the number of cats as there are pigs, and we can see here there are 20 cats and there are 40 pigs. Now what we get when we're calculating this is going to be minus a 0.5 times B1, and so therefore this is going to remain the same logic. If you look at our weighted codes, it's going to be minus 0.5 times B1, minus 0.25 times B2, and minus 0.75 times B3. And that's precisely what we get here. Whoops, sorry. And that's what we're getting. And if you notice that for unweighted effects, it was very simple because this ratio remained the same. It was a unit weight. So we could find out the expected value of our comparison group pigs here would be just B0, our intercept, minus the coefficients, the main effect coefficients, B1, B2, and B3. Now remember that This is a main effects only model, and this is precisely how we would compute this. If we had interactions, we would include all of the other coefficients as well with their appropriate coefficient weights. Okay? So the difference between weighted and unweighted effects are that the weights push all of the group mean differences toward the comparison group. And you'll notice that all of the effects, just by simply looking at the coefficients that we have for our models here in the matrix, you'll notice that my cat variable, that's my cat weighted effect, that cat still gets a 1. Similarly for my dog gets a 1 and fish gets a 1. So all of those effects remain unblemished. All of the weights go into calculating the estimated effect for pig. So remember that when we're using weights, all of the weighting goes into the comparison group. And that's a very important part of the distinguishing features between weights and unweighted effect sizes, or effects coding. So this concludes and you'll notice that I didn't go through all of the painstaking detail that I had for the previous dummy coding and effects coding, because they're pretty much the same computations. It's just weighted, and those weights, we're not going to bother with doing all of this by hand. Instead, what we're going to do is we're going to start running these models and making sure that we get the proper comparisons and that we get the proper weights if necessary. The next video, we're going to talk about contrast coding, which is the general set of codes that we've been talking about already. So stay tuned for that.